So start by making a graph of the function. We know the function is an inverse rational function which has an vertical asymptote at x equals -1 because the denominator does not exist at -1, and it has a horizontal asymptote of y equals 1 because the powers in the numerator and the denominator are the same, and the coefficients will indicate the equation of the horizontal asymptote. This is a little bit of information back from pre-calculus 12. I've also plotted the point 1, 2 here, and notice that it's not on the function, and we want to graph two tangent lines that go through that point. So I'm going to roughly graph those in. They look like that, so roughly speaking, and we don't know where this point is, so I'm going to call this A. That means that point is A, f of A. And more specifically, it's A and A over A plus 1. So I've used the function to actually find f of A. Now, what we know is that the slope of the tangent line has to be the same whether you calculate it using the derivative or you use the rise over run. So if I've calculated the derivative here for you, or found the expression for the derivative, and at A, the derivative looks like this. And the slope of the tangent line, as using rise over run, if this is 0.2 and this is 0.1, the slope of the tangent line can be written as 2 minus A over A plus 1, and the difference in the x's is 1 minus A. So these two have to be equal because they both are the slope of the tangent line. So here's the algebra. I'm just going to quickly run through it. Here's the slope of the tangent, the two formats. The slope of the tangent lines have to be equal. This is coming from the derivative, and this is coming from rise over run. So that was from the last slide. And it's a complex equation with lots of fractions, so you need to clear the fractions, and you can clear the fractions by cross multiplying and ending up with this expression. Next step is I'm going to multiply the two in the a plus 1 squared into the bracket, and that will cancel this denominator here. I now going to simplify by getting rid of the brackets, expanding the binomial terms, and you should end up with a quadratic equation that looks like this. It is not factorable, which means we need to use the quadratic formula, and we get two answers for that, which look like this. Now, what are the y coordinates for when the x coordinates are -2 plus or minus √3? Well, we plug those two values in to this function, and I've done it in detail for one of them. When I plug the value in, I notice I've got a rational in the denominator, which I need to clear by rationalizing the denominator, so that's why I'm multiplying by this. I simplify and I end up with a y value of 1 minus √3 over 2. I'd have to do the same thing again using the other point, which is this one right here. So here are my two answers. There's one point and there's the other point.